During a clash coordination meeting, have you ever gotten the question, what room are we in, or where are we in the model? Maybe you've taken to appending 2D CAD files or a 3D room tag plugin to place room names inside your Navisworks model. This works great when you're in the meeting, visually have the model up for reference, but what happens when you end that meeting and want to report out your clashes and still convey the location information where clashes occur? Well, watch this video and I will show you a method on how to use Dynamo, Navisworks clash reports, and Excel to append room names where clashes occur to your Excel report. Let's check it out. Alright, so inside Navisworks, just want to check our quick properties to make sure that those are defined as needed, and because we plan to carry that information over into the coordination report. So let's go to Options, Interface, Quick Properties, Definitions. And keep in mind, these are the quick property definitions I like to use for Revit model clashes. These will be kind of different when I'm clashing against CAD MEP objects or HydroCAD. Really any CAD-based trade file at that point. As for the definitions themselves, I've got the item name, type, layer, material, source file, and then the Revit element, system name, system type, and system classification. This is kind of redundant, but in this case, our model has some undefined systems, so I just try to catch where that happens with these other properties. Alright, so that is defined. Let's open up Clash Detective. And we have our test selected, so we can just go right on to the results, see what we're dealing with. So we've gone ahead and coordinated or clashed all these results. These are all the different issues that we've broken out. We still have a main group of clashes. If I drag this off screen here and select hide other, this is everything that we haven't clashed against. Or, I'm sorry, everything that we have not grouped into a specific clash. Whereas these are specific items. Alright, so with that, we want to produce our report. And we want the summary, the clash point, that's vital. The date found, sure, why not? We don't really care about these properties. We definitely want the layer name. That corresponds to the level. The item ID. This can be useful later, so we'll want to include it. Status, sure. We won't use it, but it might be useful later. The distance, anything that we might use later, we're going to want to include. And I like to use comments, so I'll include it. We definitely want to have our quick properties checked. This is vital because we want that information we just set to pull through. We'll keep the image checked here, even though we won't use it. Maybe we'll find a way to use it later, who knows. And then we want the grid location on the clash group. As for the status of clashes we're exporting, it's just going to be new and active. We didn't want to export these, so I've set the clash groups that correspond to these as reviewed or approved, and we're not going to export them. And then we're going to export the current test in a tabular format as an HTML file. So let's go ahead and write that report, set it somewhere, and we're going to go on our desktop here and just do make a fresh file set. So samples, yeah, fine. And new folder, HTML, and we'll be a little more clear, HTML report, and MEP per struct. Okay, we'll just keep it like that, save. Alright, that's done. Let's get that in Excel and check it out. Alright, and File Explorer is open. Let's go ahead and just verify this report, what it looks like. Let's open it up. Awesome. This is exactly what we expected to see, all of our information. And the quick properties we were talking about, those show up here. Item name, type, layer, material. Alright, so this is great. We can look at our images. Woohoo. Normal clash report, right? So let's get this into Excel. So let's just open up Excel. Just start a new document. We don't even have to do that, but open a blank document. And I like to just drag and drop. It's quickest. Let's just close that previous Excel file. Blow this up. Alright, so it looks pretty similar, right? Same kind of functionality. You can still open the images on your computer, everything. This is what the benefits of HTML, right? It can open in a browser and other things. Very data-friendly format. But we want to put this into an .xlsx or an Excel workbook file so that Dynamo can read it. There's many ways to skin this cat. We could do an XML. For simplicity's sake, I like the visual simplicity of these HTML reports. They're a little easier to read, and we'll do the data parsing and cleaning inside Dynamo. So let's just go ahead and save this as, where do we want to save? We have our samples file, and let's just go ahead and save it actually out here. No, let's call it Excel files. Title, clash report, yeah, save. Alright, so we have this Excel workbook file now with our sheet name that matches the clash report right here. Notice this is the tolerance of the clash report and all the summary that we were talking about. Anyway, this step is done. So now we have it in a format that can be read by Dynamo. So let's go ahead and do that. Alright, so we are in the MEP model with the structural model linked in. This is what created the Navisworks federated model that we were just looking at. And before we get into the guts of the actual Dynamo script, let's go ahead and run it in Dynamo Player and just see how that would work and see what the results are going to be. So let's go ahead and open Dynamo Player. We have to go to our file location that has the script. I've saved it in Dynamo Fun. And we want Clash Point Room Locator, this guy right here. So, but we don't want to hit play. Actually, we want to check our inputs. So let's edit those inputs. Clash against level 1, the level 1 rooms. The class report sheet name. And so if we look at this, that's right here, MEP verse struct with the underscores. Okay. Let's browse to the file path. And so we actually saved that somewhere else. We went to our desktop, samples, and Excel. We want the Excel report right there, MEP verse struct. Go ahead and open. I'm just realizing now there's probably an efficiency we could have here. The sheet name is equal to the file path, or the file name. So could do some quick string parsing and probably marry those two up. Alright, and now we want to create a new Excel workbook with this data at the end. Yeah, we can definitely clean up this node a little bit, but in the meantime, let's go to, what was our file path that we chose? Let's go ahead right here. Yeah, let's just grab this, paste it right in there, but we don't want to overwrite our report. We want to create a new report. So, and we don't want to do it in the Excel folder either within samples. So let's go ahead and change all of this. We get samples, backslash. Let's create a new folder called, well, I don't know if that will create a new folder, so let's just post it in samples. And we're going to call it new just clash report .xlsx, and we have to include the file suffix here too, or the file type. Alright, so we've chosen our inputs, maybe out of order, because here's the description. This is what's describing this is what is describing the inner workings of the function of the script. So we're going to input the clash test as a workbook, going to reformat the data, grab the XYZ values, create point geometry, then, or really more accurately simultaneously, we're going to grab the Revit model room elements, convert it to geometry by level. That's why we chose level up there. We have the option to get the room perimeter curves. We might use that later, we might not. It's just kind of neat. Now that we have the clash point geometry and room geometry, we are going to basically extrapolate that clash point geometry to be a vertical line, so that anywhere it pierces a room, above or below, it's going to throw an intersection. In this case, we're going to control the line so that it's projecting upwards, and we're going to normalize all the points to 1 foot above the input level elevation. And we're going to project a line upwards, so each clash point should theoretically pierce the top of a room that it's in, if it is in fact included in a room, or if a room exists where the clash point exists. So we will test that intersection. We're going to yield a bunch of true-false values with that, and we're going to use those results, those intersection results, to determine which room each clash point is located in. Once we determine that, we're going to use Dynamo to extract some of those Revit parameters from that room, such as the room name, room number, and we're going to actually grab the clash name from the original raw data Excel file, Excel clash report, just as a QC check to make sure that we're marrying up data row by row in the way that we're meaning to. Additionally, this is sort of an optional step. Nice, I can do that. This is better here. And then for that new sheet name I was just talking about right here, the optional step 5, we're going to call that unique clashes per room. These others we have frozen right now, the watch item ID and the 2 clashing items. We're watching their element IDs in case we want to use that later. But for this exercise, we're going to ignore them. All right. I think we're set. Let's go ahead and hit run. All right, so we can see here the run completed. That took less than a minute, less than 10 seconds, or about 10 seconds really. The only indication I had that this completed was run completed here, and my Excel started flashing orange because new items opened up. So this is, well, this is the Excel report we already looked at. This is our new report, the new data that came through. And let's go ahead and minimize that. All right, so what's so special about this? It's really all the same information. It's just a little harder to read now, right? Well, we've gone ahead and cleaned up some of the data so that it can be more easily consumed by a computer or any type of data analysis software such as Power BI. Yeah, ultimately, that's where we're going to go with this, is we want to start putting some of this data into a Power BI environment and visualize some of our reports so that they're more effective and it's easier to find where the clashes that are relevant to you, where they are in the building. And this opens up the doors for a little data analysis, all sorts of fun stuff. All right, so with this data, we should also be seeing, let's go ahead and select all, oops, select all of that, and let's just even out these columns a little bit. So with this data, oops, we have some blank columns here too. So we have to figure out what's going on there, because I don't really like having any null columns. But anyway, we'll leave them for now. Anyway, the point of this, we should now be seeing every single clash bubble, the clash group it's in, that's all normal, but we should see what room it's in. So for example, this duct run versus concrete beam. Actually, well, because that's a run versus beam, that could be a bunch of different rooms. So let's take all of them and let's see what rooms that this issue permeates through. And I should actually freeze. Let's go over here. All right. And we lost our spot, so we've got that frozen. Duct run, concrete beams. Let's check out what's going on with this, how many rooms these are in. System classification, these are the items. Type room name. All right, here we go. So this issue happens in the workshop, or workshop 2 rather, and the corridor. And how are our clashes looking? 511, 557. Let's check that. And 511, 557. All right. 918 is the last one. 918. All right, so we know that this data lined up correctly. So we know that the resulting rooms here are correct. They are actually where these clashes occur at this XYZ location. Also this grid line location, approximately, the J6. Anyway, so this is the results that we start to see in Excel as the raw data. And this opens up some doors when we have clean data like this. We want to start performing some analyses on them. So, for an example, some basic analysis is we can check out how many clashes occur per room and see where our trouble spots are. So this is the data that we exported from Dynamo. And let's make these columns more appropriate. Those are our titles. Let's do that. All right. And we can see that we have 7 clashes in the workshop, 31 in the MZR room, 55 in the corridor. This is great, but let's start to add some visuals to this. I like to first initially start off with some conditional formatting, color scales, and we'll do red on top, or red at the largest. Excellent. So now we can start to see, by color, where the worst offenders are, or really where we should probably prioritize. For example, this corridor, a lot of clashes going on there. And keep in mind, this is MEP versus structure. So there's a lot of structure and a lot of MEP in corridors typically. And so we expect to see this, but now we know that, hey, we should probably prioritize our corridor runs, because this is where we have the most issues. Whereas in the cafeteria and in these other locations, the water closet H, water closet D, and the stairwell, we have 1 clash. It's worth checking out, no doubt, but we should probably focus on these first and then get down to those. At the very least, it increases your chances of catching more issues, or worse issues that will be problems later on, if you check the areas where there's more clashes. Makes sense. So if we wanted to start to order these, just do some basic Excel sorting, filtering. There you go. And notice how everything that comes with it, and I went smallest to largest. I wanted to go largest to smallest. Now we can have a nice pretty gradient. Let's also get this in a pie chart. We'll do clashes per room. Insert 2D pie chart, and I love that Excel makes this very quick and simple to start doing things like this. I prefer this one, and so right, our corridor has the most clashes by this margin, and then this THPH room, MZR room, they start to go like this. Let's assign some values to these real quick. Value. All right, so now we can just start to see, and maybe you want a percentage too. Why not? So of our clashes, 27% of them occur in the corridor, 16% of them occur in the CHPH1 room, 15% of them in MZR, and you can carry on from there. So, like I said, this is some really basic stuff, but having clean data opens up the doors for this type of analysis. And now you can make more informed decisions and attack problems where they're needed most, or where it's needed most, rather than spend time on your low priority items. This assigns a priority to your clashes and to your process. All right, now that we've seen the script output, let's go ahead and dive into the Dynamo script and see how we arrive at these results. All right, we're back in Revit. Let's go ahead and close Dynamo Player and open up Dynamo. Open our script. All right. Take the full view. Yeah, so there's some steps to go over. In general, purple is Excel steps, green is general process steps. This lighter green is an optional step. These grays are optional steps that are not used in this script, but it produces good data. One of those examples being that item ID 1 and 2 of the clashing elements. The other one being like the room perimeter curves. So we've included it here. but we don't use it. It's not necessary for the script output. Orange is our output, or sorry, our inputs, mostly when naming Excel files and selecting the level of rooms that we'd like to collect and test clashes on. If we look at our steps here, first we're going to import the clash test as an Excel workbook, reformat the data, extract the clash point XYZ values, and create point geometry. So let's check that out down here. Step 1. We input our the file path for the Excel sheet, the sheet name. You can do false true. We're not going to focus on the general, some of the specifics here. Like I said, we'll provide the data set, the Excel file, everything you need to replicate these results, and you can start doing the digging into the details there. Real quick, we're going to hard code drop the top 7 rows and the last 1 row of the Excel file. Actually, this is we could theoretically drop more than this. I haven't done the exact count, so we'll leave this as it is actually right now. And the reason for that is because when let's open up our clash report real quick. When we look at our clash report here, we have all these extra rows that we don't really need, and see on the 7th row, that's where we want to drop that. And so what we end up with is our first row here is actually the titles. That's exactly what we want. So that's why we dropped the 7 rows. Might as well just add to get row. That's a little better. Let's go ahead and run our script, and it's already ran the Excel. All right, now that we've run the script, you can see what's gone on here in the background. What we result with, or we end up with, is room solids. That's what you're seeing there, and then lines piercing the top of the room solids originating from a point. Very cool. That's exactly what we want to see. Anyway, did that to illustrate the results because we're going to need that moving forward. So now that we've cleaned up our list, we can deconstruct it into the first row and the rest of the rows. Again, because we want the header row there. There's so many ways to do this. So you might come up with a better way. This is just the way I went about it. I guess it's what made sense at the time. It seems fast enough. Well, hard to tell. Small model. So haven't really got to test this on a huge model yet. Anyway, we deconstruct the data, get our column headers, and the rest we just call row data. And then we want to get the index of the clash point so that we know which column to grab. And so that's going to be column number 11. So if we look at our data here, column 11 is going to correspond to this, column L. And see, it's like a merged column, so that's why we wanted to do some cleaning here as well. See if I unmerge and center, all of that just lives in that right there, that cell. So once we have the index there, which is our column header, we're going to go ahead and get that column of data, all the XYZ values. And then we're going to parse it so that we can actually take this string of values and convert it to actual numerical values. So first, to do that, we just want to split by a comma and a space using the string split. That's going to split everything into XYZ strings still, because we have this little X thing here, or XYZ prefix. And then this is where we start to use a Python script just to make things a little easier. We want to input the sublists of XYZ, and then we're going to output, where we output here, an actual geometry point. So we take care of all of this inside the Python script. And that kind of makes it easy. Here's the description right here. I'll let you go ahead and read that, but if we open this up, this is the script that we're using here. This is all the generic stuff. Here is the input, and then this is the actual code right here. So we'll focus this down a little bit. because I'm in Revit 2022 and the latest version of Dynamo, I'm also using the latest version of Python. So I do believe if you're using Iron Python version 2.7, this may not work. There's some stuff in Python that's been added, but I just can't be sure. To be honest, I don't know if it will break it or not, but if you want it to work, use all of the same file versions. Anyway, the actual code. So first we want to initialize a blank list of temp XYZ values. This is going to be relevant later, so that we can just collect each of these XYZs temporarily, do something with it, and then wipe them clean and do it again for the next batch of values. And then we're going to, this is going to be our output, our clash points geometry. This is where we're going to end up with at the end of the script. Our clash points, what we're calling our clash points variable, that's the input of all of this right here. This is our clash points, this 603 length list. So for clash point and clash points, so for each sublist in the list of clash points, we want to get the string value of the position, or the items in the second position onward, second index position onward. Also, don't forget, if you're here, you already know this. This is a zero-based index, so 0, 1, 2. That's 0, 1, 2. So the 2 starts here. We want this number onward. That's how we're purging the first two items. You could do this the opposite way and just drop 1, 2 of each string. You know, like I said, there's a million ways to do this. Some ways may be better than the others in terms of using computer resources or being more legible to someone reading the code. You know, it's really going to be up to you. I would prioritize computer resources. If you have a faster script or a faster way to do things, that's ultimately going to scale better. So going through the rest of the Python script here, after we've got in the actual number, it's still in a string format. Let's go ahead and convert it to a floating point format. And then in that the temporary XYZ list, we're going to append that float value. So that's going to grab X, Y, Z, and then we're going to assign those to their own independent variable from that list. And I wrote it this way just because this is much more legible and Pythonic, I feel like, at least, to understand. So our X value is here, the 23.06, the Y value is 77.582, and the Z is right there. Now let's create a new point. This is where we start to use the Dynamo proto-geometry library. So we're going to say point by coordinates, and we're going to make it at the XYZ coordinates that we just defined right here. And we're going to take that new point and add it to our output list, which is the clash points geometry here. So append the new point, and finally we're going to reset the temporary XYZ list or collection of values to be used again in the next iteration. And I guess actually finally output the clash points geometry list here that should be populated. All right, so that is the Python script. I like, anytime I use like a for loop or a nested for loop, I definitely like to make it programmatically rather than use Dynamo for it. All right, so now that we have a list of point geometry of our clash points, let's go ahead and turn this preview on so we can see what those look like. And obviously the first thing I notice is they're out of place, and we'll handle that in just a second. But you can see like the difference in elevations here. While ever so slightly different, they are different, and there's even a clash down there. So we want to normalize these elevations because you can also see that most of these clash points that occur, they're actually above the room geometry for the level that we're testing. And this is to be expected. We expect rooms in Revit to sort of end, or at the top, they will top out at the bottom of ceiling. In most cases. They may not in all cases, but that's the space that the room is actually enclosed in, and the plenum space above the ceiling is not necessarily part of the room. And so this is functioning exactly as expected. So to get around this, we want to project these points downward in the Z direction so that they can end up in the room, so that we can actually test physically if that point, or that clash point, that point geometry, is inside the room. So how do we do this? Well, step one, we got to project these points downward. And so what we'll do is we'll take this point geometry, grab just their z values, grab the level information from the level that we've selected, the project elevation, which happens to be 0 in this case, makes it easy. We don't care about civil elevations, we just need a relative elevation here. So we grab the elevation, the point z value, and then we want to measure the difference between those two, which is this equation right here. The difference is the point z minus the level elevation. So that in this example would be 10.93 minus 0. So the difference is 10.93. And then we're going to subtract an elevation buffer off of that. And we set that equal to 2. And so what this is telling Dynamo, place this point 2 feet above this level, essentially, right? So we're going to take 2 off of the difference so that the projected point, instead of getting projected all the way down to the level, it's going to be projected 2 feet above it. And this is because we don't know exactly where these levels start at the ground level. We don't know if they're at a finished floor or top of slab, and we don't know where that level is placed in relation to those. So we're going to give ourselves a little 2-foot buffer and put the points 2 feet in the space, and it's very unlikely we'll have a room that's less than 2 feet in height, so this should work out great. All right, so we calculate the difference. We scale the a unit vector, a z-axis unit vector, to be equal to that difference using the vector scale function. And then we take all of our points and just pass them through. So we could even just connect all points here to all points there, same difference. It's even a little more clear actually doing that, but we'll just keep it like this. Now that we have the difference and the direction that we want to project the points, which is downward, the downward z direction, we can create a list of new points by using the point subtract node, which would look like this. Point subtract. And so we just typed it out here. Takes in all the points that we'd like to adjust, and then the vector that we're using to adjust them with, and that vector is the unit vector scaled. All right, so that is the level elevation real quick. We'll jump over here to the translating the coordinates to be in the right spot. All right, so this is a perfect example because you will probably run into this issue when you try this in practice. So we have the MEP model and the architectural model and the structural model all using shared coordinates to align themselves together, which is great, but for whatever reason the MEP model does not have the same internal coordinates as the architectural and structural do. So this is kind of a challenge, an ongoing challenge within Dynamo is using shared coordinates and coordinate systems. Dynamo will read the internal coordinate system, at least as I understand it, but if that is no longer true, please correct me if I'm wrong out there, community. Thank you. So as I understand it, Dynamo reads the internal coordinates. That's why these MEP model, these clashes, which came from our Navis model, remember, which is using internal coordinates, that's where these points originated from. And so we want to adjust them by a common translation to get them lined up with the architectural. We can easily do this in the Revit model. If we go to like a plan view, for instance, we used grid lines to align ourselves up here. The A1 grid line, which is this here, we just kind of took those from both projects and manually lined it up, saved the coordinates back to the previous Revit model, to the MEP model, or whichever the process you use. So by doing that, we are able to get a translation amount both in the Y direction and, in the X direction and in the Y direction. So we're going to move in the negative X and in the negative Y. So let's go ahead and do that in Dynamo using the known distance from that A1 grid intersection. So this is that known distance. We need to translate 40.297 feet in X and 40.625 feet in Y. And the direction, so notice these are positive, just absolute values. We're going to handle the direction negative X here, vector scale. So I wonder actually if I can just do the vector x-axis and make this a negative number. That kind of simplifies the script a little bit. Well, you know what? Just for the sake of this, I'm not going to do that right now. We're going to explain it like this, but just know that you can also, there's many ways to do this. Like with most Dynamo scripts, there's many ways to do a single thing. All right, so to actually translate this geometry, we wanted to take our new projected points, our level projected points. So the z value's already been adjusted to that 2-foot buffer. Move them in the negative x direction by using the vector scale again by times -1. So we move that by our x translation, and then we do it again, negative y direction by this amount. Very similar numbers, slightly different. And so if we were to then turn off our points here, oops. We should, at this point, we'll see points, but we need to get the rooms out of here. And here's the room geometry. All right, so if I select this, all these points should turn blue, and they do. So this is the final location of our points. Excellent. All right, so that's the quick geometry translation we had to do. You may or may not have to do that on your projects. It'll depend on how the coordinates have been set up. If you're lucky and everything's internally aligned, you won't have to do it. If you're using shared coordinates and one model is not in that same internal coordinate system, which is very likely when you have consultants who are from different firms and whatnot, you'll have to figure out the translation and do some translating. So moving right along, now that we have our geometry translated, let's go ahead and turn our room geometry on. Actually, let's double back to that because that's the part of the script that we are at. We look at our description. So we projected the clash point geometry to a common elevation. We're skipping around a little bit. We have yet to draw vertical lines and the test intersections because we need our room geometry first. So let's go ahead and do that. We're going to get all elements of the rooms category. Here's all the Revit elements. And then we're going to filter these by our selected level. So let's get their level parameter, get the name of the level that we've selected, test if they are equal to each other, get a bunch of true, trues, false, false, whatever, and use this filter by Boolean mask to select only the room elements that match the level that we care about. And then we'll go ahead and take the geometry of that right there, which is just usually rectangular prism like. Or rectangular extrusions, I guess is more accurate. Rectangular solids. We're going to flatten it just because of the data structure. It comes in like that. And this is where we would get room geometry curves or perimeter curves. We don't need to worry about that for this step of the process, but it can be kind of neat. A quick visual. I wonder if this is going to run. Originally, I was planning on using a polygon test to check if the points was inside the room perimeter curves. Realized that was overkill. I can just test whether the point is included in the actual geometry. But I kept this out that piece of algorithm around because this is kind of interesting. I might end up using it later. Anyway, options there for you. Have fun with it. If you do find something cool to do, please feel free to share, because I would love to see that. All right, so we don't care about that though right now. We just want the room geometry, and so we already accomplished that, and so we're going to move on ahead here, and we're going to pass this now into the step that we were just talking about. We're going to do our tests. So with our room geometry and points, we need to create an element that we can actually physically clash against here. And that element is going to be a line projected straight up from the point. Preview these. And you can see that these lines pierce the top of the room, and that's going to be necessary because we need that physical intersection between geometries. So in order to achieve that, we set the line height equal to 12, with the reasoning that most floors are going to be 12 feet high. Don't forget we have a 2-foot buffer, so this will catch all 14-foot high rooms. If you have let's say a huge lobby space or something like that, an auditorium or large feature space, you might have to set this value to like 20 or 30 to make sure to hit the top of the room geometry that you're trying to clash against. So once we have those lines drawn, and we just draw them directly straight up, and the length of 12, like I said, from our points, from our point geometry. Now we're going to use the geometry does intersect node, and we're going to turn it on cross product. So we test every single piece of room geometry against every single line. So the way that works logically is take room number 1. Does it hit this line? Yes, no. Does it hit this line? Does it hit this line? Go through all 201 lines. Then we'll go to the next room object. So solid number 2, right there. Does it hit? Same thing. Does it hit any of these 201 lines? And so where it does, then it will come across all of these that it does hit, and it'll yield a true. So this yields Boolean value, like you can see there. So false, bunch of falses, and eventually you will see a true somewhere. There's a couple. True, true, true. So those are clash points that are signaling that they are indeed inside the room because they intersect with the room geometry. I love to use this all the time in terms of finding when something is close to something else or in something else or whatever. The geometry intersection tools in Dynamo are very powerful. All right, so now that we have a list of Booleans, again, you could go about this a bunch of different ways. You could use a list filter mask and try and keep track of all the lacing and whatnot. I went ahead and used a Python script because for me that was just easier to keep track of and a little more succinct in terms of processing the data. You know, you don't need so much of the spaghetti nodes, and we can go into it right here, but this is what it takes in as inputs. The Booleans, the Revit room elements, and note that this is room elements and not geometry. So this is the native Revit stuff. The list of clash names from Excel is going to be down here. That is just the column of strings from clash names from that raw Excel data. And then we're going to transpose and append our trimmed and cleaned Excel data. And the reason we want to transpose it is because it just becomes a little easier inside the Python script to append new things to the end of each of these lists. Again, this is just the way I did it. There will be other ways that you find to do that. And so here's the trimmed Excel data. We take in our, like I said, trimmed Excel data from before, we transpose it, and then after we transpose, we're actually going to drop the last 20 lines because this, if you look down here, it's all nulls. The last 20 groups here are going to be nulls. Yeah, so we just get rid of them, and this really should be a manual input thing, shouldn't it? Because I had to figure out the 20 experimentally. You could either look at the Excel file, you could look at your watch nodes, and then adjust as necessary. This number will depend on which properties you export with your Navisworks clash report. If you followed the export settings and properties and all that to a T earlier in the video, then you can just use this number and it'll work out just fine. So let me just remove this from the group real quick and call this an input and number of rows to remove from bottom. So we drop those last 20 items. We arrive at this cleaner, ironically nulls, but we get the clash name. Those lists, we're going to purge those out actually in a later step. We really should do it right here because that would make the most sense. Any case. All right, so let's dive into the Python script. After we've cleaned up our Excel data, we've got our clash names, we've got a Boolean value, true, falses, and we've got our Revit room elements. All right, I realized I didn't have my mouse capture on. Sorry about that, team. Hopefully you're able to follow along those previous steps. I want to keep powering through here. So with the PyScript, right-click Edit. Let's see what we got going on here. So remember, these are our inputs. There we go. All the normal stuff. Probably a little overkill going on here. That's all right. Here's the inputs we set, just like per this this note. All right, and we're going to initialize some variables here. We're going to call I and J, and I collection and J collection, these lists. And so I and J, they track the index that we're in when we're iterating through the rooms that we've gone through and the clashes per room that we've gone through. So the rooms is going to be the I index value, and the clash points per each room is going to be j. The new rows, oh actually, and you know what, I don't even think we use, oh no we do, okay. We want to initialize a blank list of new rows. This is going to be the new data we add to our Excel, and so we're going to have to add that in. And then the number of clashes that we're dealing with, that's just going to be the length of the list of the Booleans. And so we want to grab the first one, the first item out of that list of Booleans, because this is like a multi-level list, multi-layer list. And so each sub-list here is going to match the number of clashes, and the total number, the parent lists of those sub-lists are going to match the total number of rooms. All right. So for n, for the number in range of the number of clashes, right, we want to append any, in this we want to append a blank list. So this is just our way of creating a second degree or second order list, blank list. We initialized it by doing these two steps. All right, and right off the bat, we are going to use that blank list and create our actual variable collectors here by using that blank list and the copy function. And the reason you have to use this copy function is because if I just set room names equal to new rows, this is pointing directly at new rows, so they are sharing a space in memory. And if I did the same thing here, everything is pointing to the same single list. So if I made a change to room names, it would change new rows. If I've changed new rows, it would change room names and room numbers because they're pointing here. Same thing, like if I change room numbers, it would change new rows, which would change room names. They'd all be linked. So you have to include this copy to make them unique. It's like duplicate your materials in Revit, same kind of idea. All right, so now we have our blank two-layer lists, really, I guess, arrays, matrices, maybe you want to call it. Initialized at this point, we can go ahead and start populating information. So we want to iterate through each of the room solids in that list, like I was saying. That's this level 2 of the intersection booleans. And in each of these rooms, we want to find where we get a true, because that means that the clash is inside that room. So for room in intersect booleans, that's level 2. And then for line, the line test in the room, that's here. That's level 1, a bunch of true falses. If the line test is equal to true, meaning the clash is inside the room, then we want to collect the position that we're in. So that's the I. This is where we use that I and j variables. Position I, that's the room. We're up here. This is going to be I, and this is going to be j. So just realized this is from an old piece of code. This I and j collection, we actually don't need these. We're doing it live, I guess. We were using these before to keep a running tally of where these clashes occurred and which room they occurred in by keeping track of index locations. We've gone ahead and just done away with that. We've gone on a different method here. So I'll include it in the script, but actually no, I won't, because you don't need it. Let's keep things simple. But it's a method out there. Anyway, so where were we? We were saying if the line test is equal to true, meaning that there does exist a clash inside the room, then we want to take oh, sorry, nope, we're not even there yet. We want to go current room element. We're going to create a variable here and set it equal to the room element of I. This is why we were tracking this, and this is why we wanted the room element's input. So now we can grab that room element, and we get the current clash name, doing the same thing, clash name of j, because we go rooms, clash names. This is why we took our clash name input in right there. And so this will give us the current Revit element and the current clash name, and then we, using that Revit room element, we get the name and the room number, and then we convert those results, those parameters, to a value string, so that we can actually, so it's a string that we can append into a list. And then we do the same thing here, or I'm sorry, we populate our other blank list here with the clash name from that corresponding row, and this is going to be our QC check. So if you recall from earlier in the video, this QC check corresponds to the name of the clash, and all we're doing is just kind of copy and pasting the clash name over here over to the end of all of this data, just to make sure that all the data in each row stayed aligned. So that's all that that's accomplishing right there. Okay, once we have that information appended to our collector list here, we are done with that line test for that point. We're still in the same room, but that individual clash point has been tested, so we move on to the next one. The way we do that is we want to keep track of our count, so we're going to iterate 1, j plus 1 at the end of our if statement here. And we don't want to put it in the if statement because you only enter this if statement if there is a clash in a room, if it's true. And we want this counter to count after every single line test, after we go through every single line test, regardless whether it's true or not. So we add 1 to our clash point counter, and now we're still inside this for loop, and so this is going to go through all of the line tests for that room. Once we reach the end of this for loop, we are going to add 1 to our room index counter. Same reason. So the for loop is automatically going to move to the next room, but we just want to track the index location, I guess you call it manually, here with these I and j values. Also, we're going to reset the j value here. So that's our line test counter. And the reason for that is there's only 200 and 202, 201 indices, or 202 I guess total length. But 201 index positions within this line test within the clash points. That's how many clashes that we threw. So actually another check, this should be 202 rows long. 203, okay, because we have a blank row on top. So yeah, awesome. That lines up perfectly. That's where that number's coming from. So once we've gone through every single one of those clashes and tested them on the room, we want to reset that value to 0 again, so that the next room that we go into, our j counter is reset to 0, and we're once again going through each of these clashes 0 to 202. Instead of, if we didn't do this, this would just keep on counting from 202 to 203 to 204, and we'd get an error thrown index value out of range. So we reset the counter there. Talked about this, not needed, just go ahead and delete it. And here comes the output. So we take our data that we've collected here in these collector lists that we initialized. We've now populated them, and so we're just going to insert a title onto each of those lists at the 0 index position using the insert method. And here's the title that we're inserting. It's just a string, room number, or room name, room number, and the clash name check. We can call this QC check. And I want to hit space. All right, and then to actually append these new rows of data into our Excel data that we want to export, we're going to essentially just append that to the back of our transposed Excel data. And this is why we input this, so that we can add to it and export it. So for the new column in room names, room numbers, clash name check, remember that's our collection. Each of these is a new column that we want to add. So this is just a succinct way of writing it. So for the new column, let's just append that new column to our transposed Excel data. And this is why we wanted to transpose it, because we're collecting it by column. If we didn't transpose, we'd be adding a new column as a row, and that would just screw up the information. It wouldn't be right. So once the new data that we've collected through the script is added to our Excel data, we can just re-export that now. And so what this looks like is at the end of our list here, we'll see columns with room names, and the last one room number. The last one should be clash QC check, clash name check. So I haven't run the script since I renamed that in there. That's why this is different. But this totally jives with what we expected to see based on our Excel report here. The last column we're going to see is that clash name check. So this is, we've now checked our data, and that's all validated. Oops, script went down there. And at this point, we're ready to export this to an official Excel file format. So at this point, we've reached the end of our minimum viable product here, because this is going to export all the data that we were looking for, that the room names, room number, and the clash name QC check, to our cleaned Excel file format, which is this here, cleaned. If we went to the end columns, we'd see room name, number, and clash name. And now let's say that we want to quantify the number of clashes that occur in each room. You could do that in Excel here. If you like doing Excel or Excel Whiz, I'm going to show you how to do it in Dynamo, because why not just click the button once and have the script do it all kind of for you, or at least do some of the heavy lifting to make whatever you want to do in Excel afterwards easier. So that was this node to get our actual information. So now let's start to mess with the data a little bit and manipulate it how we want, or at least to view, so that we can view what we want in Excel. So we're going to grab the room name column, just doing this by getting its index location in the list we created. It's not the most efficient, but this works. It's fine. And then we're going to group header values. Group header room name, and get the list of unique room names where the clashes occur. So we're just going to drop that room name header that we previously added on. Like I said, not the most efficient, but it works. So that we're left with just our data again. And then we're going to pare that down into unique items. So now we have just our unique items, or unique room names where clashes have occurred on level 1. Right? And so if we get the count of that, so we have 21 rooms, basically. 21 unique room names where clashes have occurred. And remember, our list before was 33. So it'd be accurate to say some rooms or some rooms are named the same thing. Or more accurately, a room might not have clashes in it. So that's why this list could be shorter. In any case, we're going to get the unique room names, and then we're going to create another Boolean list mask, basically, just like we were doing before, and set, but this time we're not going to use equals, the hard equals. We're going to use the soft equals, which is this list.equals node, which is different than this. I'm sorry, this one. This is kind of the same thing, this tolerance, but I like to use these for numbers, and these are for any other type of data, really. So this is testing, does my unique room name equal this, equal that, equal that, equal that, equal that? And so we get a list of true, false values, and then we remember we had to change the lacing on that to cross product, and then we're going to count if true, and we're going to change the lacing again to longest, so that we're just, for each of these object A's, which is the unique room names, how many times does true occur in its list? So how many times did we see true, the room name pop up over here? Make sense? I know describing it verbally probably isn't the best, but it's the same exact, nested for loop situation that we were going over with the Python script and the room names versus clash points in the rooms. All right, so we count if true, and so now we have a list of numbers that correspond to the number of times the room name appears in the clash report. And so we're just going to create 2 quick columns of data for that, call it unique room names of that unique items we just created, and the count if true, the clashes per room, that list of numbers that we just created. And we are going to add an item to the front of it. This is going to be our header, our column title, unique room names, clashes per room, create a new list, do the exact same thing that we were doing, count how long that list is, and so that we can place data at our start columns accurately. I'm going to start the rows here at 1, just because overwrite also set to false. We're going to use the same file path as before, so we're not even going to reset that information. Just it's going to be in the same worksheet, workbook, but we are going to create a new worksheet. Call it unique clashes per room. And so what this results in, if this was our raw data, our clean, not our raw data, this is our clean data. Well, this is the other sheet that we were talking about and started to do our data analysis with. Again, very basic stuff, but this is where you start to open the doors with your data. Dynamo can start cleaning data in order to make it more consumable, more usable, and ultimately derive more decisions out of when you can visualize it in such a way that's consumable, such as this. Alright, so there you have it. That is how you can export your clash report into Excel, import into Dynamo, and then link up those clash names to the room that they occur in. So what this does for you is allows you to better track your clash coordination efforts by using this cleaner Excel formatted report structure. It also opens up the doors for further in-depth data analysis, such as visualizing your clash results in, say, a Power BI environment. That is all I have for you folks today. Thank you for watching. If you enjoyed it, please leave a thumbs up. If not, please leave a comment. I'd love to hear your thoughts and what we can do better in the future. That is all, and hope to catch you next week for our next video and blog post. See you all then.